Hi guys, today we're going to work on lesson 8-7, factoring special cases. Our objective for the day is to factor perfect square trinomials and the difference of two squares. So this goes back to lesson 8-4 when we were distributing these special cases, and we said it'd come back a little bit later, and here we are. So problems 1 and 2, we're dealing with perfect square trinomials. And we have our little take note box from the textbook. It's on page 523 if you want to reference it. But basically what we're looking for is we're trying to identify are the first and last terms of the trinomial perfect squares, and is the middle term twice the product of the first term and the last term. Alright, so if we look at this, we've got x squared plus 6x plus 9. Is the first term a perfect square? Yes, it's x. Is our second term a perfect square? Yes, it's 9. So we take the square root of that and we've got 3's. And now they're both addition, so we just put a plus sign in there. Is that 6x twice the product of one term or one factor in the next? It is. Ms. Zirzo's double checking with FOIL. X squared plus 3x plus 9, which reduces to x squared plus 6x plus 9. All right. So now let's take a look at letter B. We've got x squared minus 14x plus 49. Is x squared a perfect square? Yes, it's just x. Is 49 a perfect square? Yes, it's 7. Now we've got a negative 14, so we need to subtract both of these terms. X minus 7 times x minus 7. So those middle two terms, when we do our FOIL, would have negative 7x minus 7x, which would give us negative 14x, and our negative 7 times negative 7 is a positive 49. All right, letter C. We've got n squared minus 4n plus 4. And is the first term a perfect square? It is. It's just n. Our last term is a perfect square, so we put in the 2. And we've got a minus 4, so we're subtracting. It's minus 2 on both pieces. All right, letter D, 16c squared minus 72c plus 81. We've got a perfect square there, which is 4c. Positive 81 breaks down into 9's. And now we have a minus 72c. We are subtracting the two terms.
You're never going to get any of these wrong if you're using FOIL to check.
Absolutely. All right, 9x squared plus 24x plus 16. The first term, can we take the square root of that? I believe we can. It's going to be 3x. And the last term, a positive 16, that's going to be 4. And our middle term is a plus 24, so we're adding both terms. And we can see where that 24 comes from. 3 times 4 is 12, times 2 is 24. We said that middle term is twice the product of the first and last terms. So 3 times 4 times 2. All right. Letter F, we are building a square patio, and the area of the patio is 49x squared minus 42x plus 9. We want to know what is the length of one side of the patio. So we can factor that. 49x squared, that looks like a perfect square to me, and it's 7x. Positive 9 plus 3. And we've got a negative 42, so we need to be subtracting both of those terms. 7x minus 3. And since it's a square, one side is the length for all of the sides. Go off. There you go. All right. Moving on to problems 3 and 4, factoring a difference of two squares. Again, we have our key concept with some examples from the book, page 525. But what we're mainly looking for here is, do we have two terms that are both perfect squares, and is one being subtracted from the other? Thus the rule, the difference of two squares. We are subtracting two squares. So we have a subtraction sign. We have two perfect squares. So we put in our x's. The square root of 100 is 10. One is going to be added, and one is going to be subtracted. X plus 10, x minus 10. The reason this works, when we FOIL it, we get x squared plus 10x minus 10x minus 100. Our middle terms cancel out, and we're just left with x squared minus 100. All right, letter B, we've got u squared minus 16. Our first term is just going to be a u, and 16 square root is 4. And we are adding one and subtracting the other.
No way to get these wrong.
Nope. Letter C, 9n squared minus 25. 9n squared, square root of that is 3n. And 25 square root is 5. One is added, one is subtracted. Same approach for letter D. 25c squared, we take the square root of that, we've got 5c and a 64. So we have our 8s, one is added, one is subtracted. Pretty simple, pretty straightforward. Problem 5. First, we need to factor out a common factor. Please don't forget this. It will make your life difficult if you do. So, what common factor do we have in 12x squared and 48? I see that we can take out a 12. So we're left with x squared minus 4. And now we can factor that further, because I see that that's a difference of two squares. We put in our x's, we put in our 2's, one is being added, one is being subtracted. So your final factored form of 12x squared minus 48 is 12 times the quantity x plus 2 times the quantity x minus 2. That entire thing is what you're looking for when we ask you to factor it. All right. Letter B, common factor. I look at that small constant there of a 3, so we can divide that from each of our terms. So we'll have 4x squared plus 4x plus 1. All right. We can factor this. We have 4x squared. We have our positive 1. Now, what factors of 4 add up to 4? Well, 1 and 4, that doesn't really work. How about 2 and 2? So we'll have a 2x in each box. Look for our common factors. In the first row, we have a 2x. In the second row, we have a 1. First row, 2x. Second row, 1. Hey, look, that was one of those perfect square trinomials. You didn't even have to do the box. All right, letter C, 12n squared minus 3. We can factor out a 3 from both terms. So we're left with 4n squared minus 1. Those look like a difference of two perfect squares to me. So we have 2n and 1, and we're adding 1 and subtracting 1. And that is the notes for today. We will see you in class tomorrow.